everyone, welcome back. I'm Domingos. I'm also known as DMA and appreciate when I'm called DMA. So today we have this problem. We have f of z equal to cos of 2z, and they are asking us to write f of z in terms of the real part of f of z plus the imaginary part of f of z. Okay, so what we can do, we can first work cos of 2z. We know that cos of theta can be written as Euler to the power theta I plus Euler to the power minus theta I over 2. Okay, if we know this identity, then we can find cos of 2z. So cos of 2z will be equal to Euler to, now 2z will become our theta. So it's going to be 2zi plus Euler to the power minus 2zi over 2. Okay, now what is z? Since z is a complex number, we can define z to be a plus bi, whereby a is the imaginary part of a and a is the real part, and b is the imaginary part of z. Okay, now doing that, we can replace here. So we can say that f of z will be equal to these expressions the same as this expression. But where there is z, we can substitute by the z normal expression, which is a plus bi. Why? Because z is a complex number. Okay, so we're going to have Euler to the power 2 times a plus bi times I plus Euler to the power minus 2 a plus bi times I over 2. Okay, f of z will be equal to, now if we check, this I can multiply. So we're going to have Euler to the power 2i a. 2i when multiplies bi, we're going to have the e is going to be squared, and i is going to be squared, and I squared is negative 1. So negative 1, then that means we're going to have minus 2b. Why negative? Because I squared is negative 1. So plus, then we have Euler to the power minus 2ai, and minus 2i times bi. I is going to be squared, will be negative 1, with this negative will be plus. So we're going to have plus 2b over 2. Okay, now we can separate, because we know we can separate each one with the base. If they're subtracting, that means they were dividing. So we can write f of z in terms of Euler to the power 2a times Euler to the power minus 2b, here is I, plus Euler to the power minus 2ai times Euler to the power 2b, okay, over 2. Now, having that, what we can do? We can apply Euler formula here. So we can remember ourselves that Euler to the power theta I is cos theta plus I sine theta. Okay, having that in mind, then we can apply this identity here. So we're going to have f of z, it's going to be equal to, if we apply here, we're going to have cos of 2a plus I sine of 2a times e to the power minus 2b plus the same we apply here, the same approach. So what are we going to have? We're going to have cos. Since cos is even function, then cos of minus 2a is the same as cos of 2a, but sine is odd function, so it's going to be minus sine, we can start with I, minus I sine of 2a times e to the power 2b over 2. Okay, over 2. Now we can multiply this expression with those two, and this expression with those two expressions. Okay, doing that, then we're gonna have that f of z is gonna be equal, when it multiplies here, we're going to have Euler to the power minus 2b cos of 2a. And then when it multiplies this expression also, why not here first? Because here there is imaginary number, so I will work with the imaginary number. So this multiplies this expression. We have here plus cos of 2a times Euler to the power 2b, okay, over 2. That's the real part that we have. Now this multiplies here and this multiply here so that we get the imaginary part. Okay, all right. So when it multiplies here, we're going to have, this is going to be plus, this is a common 2. When it multiplies there, we're going to have Euler to the power minus 2b sine of 2a. And when it multiplies here, we have minus Euler to the power 2b sine of 2a. Since they were both with I, so I factorize I over 2. So that means f of z can be written as, we can factorize cos of a, so we're going to have cos of 2a, Euler to the power 2b, plus Euler to the power minus 2b, over 2, plus, here we can do the same, we can factorize sine of 2a, sinus of 2a, Euler to the power minus 2b minus Euler to the power 2b over 2i, because the denominator we can separate them. So that means this is the real part of f of z, and this part here is the imaginary part of f of z. So this is the imaginary part and this is the real part. Okay. So if you enjoy, leave your like, your comment, subscribe, and most importantly, share with your friends.